In this video, we're going to talk more about empirical and theoretical probability. First, we're going to talk about the law of large numbers. It states that the more repetitions that we do of an experiment, the closer our empirical probability will get to the theoretical probability. So we saw our example earlier. We got an empirical probability of 20%. You might have gotten something slightly different from that if you did the experiment on your own, and our theoretical probability is 25%. That's with doing 20 trials. So if we had done more than 20 trials, then we most likely would have gotten something closer to 25%. So what we're going to do is use this applet. So you're going to click on the link, and here's what the applet looks like. This is going to be tossing a coin. So when you toss a coin, you can get heads or tails. And on any one toss, it'll either turn up heads or tails. What we're going to do is keep track of how many times heads turns up. So what we're going to do here is we're going to check the box that says show true probability. And we're looking at the probability of heads being 0.5. So you have a 50% chance of getting heads, a 50% chance of getting tails. In other words, it's a regular fair coin. So if we do 15 tosses, we're going to click on the toss button to do those, and then we see what happens with the graph. So as we can see, we kind of have some big jumps here at the beginning, but as we go through, we get smaller movements, and it kind of settles near the line. So I'm going to do some more tosses here. I'm going to do 25 more tosses. And we see that now it's gone below the line, so we're at a fewer than half of them are heads, but we still are pretty close to that green line. So now I'm going to do, let's see, another 50 tosses here. And I can also see the actual numbers here up above the graph and how close they are to 0.5. So now I'm kind of getting a little further away from my 0.5 line, but I can see that the change is not very much. So I had bigger jumps at the beginning, and now it's leveling off a lot more. So finally, I'm going to do 100 tosses. And it's gradually getting back close up to that green line again. And finally, what I want to do is start over, reset, and change the probability of heads to 0.25, and then do another 100 tosses with that. So I'm going to click the reset button, change my probability to 0.25, and now do 100 tosses, and see what happens with my graph with regards to the green line. So I have some big jumps at the beginning, and now I see it's kind of moving up and down a little bit, but pretty close to that green line. So I observe that as the number of tosses increases, the proportion of heads levels off near the probability, the true probability line. There are larger jumps in the first few tosses and smaller movements after that. So next, what we're going to do is complete the table to show all possible sums when rolling two dice. So we're going to do some practice calculating theoretical probabilities here. So now this is an addition table. So we are adding the two numbers in the row and column to get the number that goes in the box. So go ahead and fill this out. You can pause if you would like and fill it in on your own. So that's what I should get. Now we're going to use the table to calculate the following theoretical probabilities. The first is that you roll 2 dice and a sum of 7 turns up. So we're going to look in our table and identify all of these 7s. And if I look here, I should see that there are 6 ways for me to roll a 7. And that is out of 36 possible ways that I could roll 2 dice, and then the sum that I get when I add the 2 numbers. So for part A, my answer here is 6 out of 36, which I can simplify to 1/6. So we're going to need to practice a little bit of simplifying fractions here in the homework, because they're generally going to ask you to simplify the fractions. So part B is you roll 2 dice and a sum of 11 turns up. So where are the 11s? I'll highlight in a different color here. They're going to be green. We have an 11 here, and we have an 11 here. So we have 2 ways to roll 11 out of a total of 36 possibilities. So 2 out of 36. And then remember, simplifying fractions, you're thinking about what factor both numbers can be divisible by. They both can be divided by 2. So I can take out a factor of 2 from the top and bottom numbers and get 1/18. Question C. You roll 2 dice and a sum less than 4 turns up. Less than 4 means it can't be 4. It could be 3 or it could be 2. So we'll use blue this time. So our possibilities are these 2 possibilities for 3 and 1 possibility for 2. So 3 total ways that I could roll a number less than 4. If it was 4 or less, then I would say I could include the 4s, but I'm not going to include the 4s because less than 4 means it can't be 4. So 3 out of 36, these 3 ways, and that simplifies to 1/12 if I divide both numbers by 3. Part D, you roll 2 dice and a sum of 12 turns up. So looking at my table here, there is one way for me to get a 12. I have to get double 6s. That's the only way. So that would be 1 out of 36. I can't simplify that since I can't take any factors out of both numbers, so just 1 out of 36. Part E, you roll 2 dice and a sum of 13 turns up. So looking at my table, there's no way for me to roll 2 dice. If I'm using regular dice that go from 1 to 6, there's no way to get a 13. I would either need more dice or different numbers on the dice, but there are no ways to get 13, and so that probability is 0. 0 out of 36, which is 0. So if it is impossible for something to happen, the probability is 0. Part F is you roll 2 dice and a sum less than 13 turns up. So all of the numbers in the table are less than 13. Regardless of what I roll, when I add the 2 numbers together, I am definitely going to get something that is less than 13. It's impossible not to get something that is less than 13. So 36 out of 36, which simplifies to 1. So if something is definitely going to happen or guaranteed to happen, then the probability is 1. And all probabilities are between 0 and 1. So if something is definitely not going to happen, probability is 0. If something is possible to happen but not very likely, then it's going to be a decimal number between 0 and 1 that is closer to 0. If something is pretty likely to happen, it's going to be closer to 1, and then definitely going to happen is 1. So question 4 says which is more likely to happen, rolling a sum less than 4 or rolling a sum of 7. So if we compare our 2 values here that we got, probability of rolling a 7 is 6/36, and the probability of rolling a sum less than 4 is 3/36. 6/36 is a greater number, so that's a higher probability, and higher probability means that it's more likely to happen. So something with a higher probability, a larger number, is more likely to happen. Rolling a sum of 7 has a probability of 6/36, and rolling a sum less than 4 has probability 3/36. Notice I'm leaving these in the 36 to compare them because it's easier to compare fractions when they have the same denominator. Not that I can't compare them in another way, but that's just an easy way to do it. So rolling a sum of 7 is more likely.